Today, just so you know, what we're doing, we've got Nelson Osacky here with us doing the presentation, not just another modularization talk, scaling Android build with Gradle. After he's done talking, stick with us because we've got an awesome panel discussion. As you can see, we're really happy to welcome with us Ivan Gavrilovich, Zach Swears, Israel Camacho, John Rodriguez. It doesn't get more experience than this in terms of lineup, talking about all things Android builds, performance, speed, features. So stack up your questions too. This is a really good opportunity for you guys out there to ask and get answers to all the questions that you've been wanting to know. So we are really excited to have them with us, and we'll be having them join the panel, join this just as soon as we've given Nelson a bit of time to do his Q&A. So that is it for me. What I'm going to do is now get out of the way, turn the time over to Nelson here, make him the presenter, and he'll be able to share his screen with you.
My name is Nelson Osacky, and I will be presenting about scaling your Android build with Gradle. So a little bit of background about me. I've been previously an Android engineer. I've worked at several different companies, from large projects such as SoundCloud and Square to very tiny startups. So I've seen all kinds of Android builds. I've seen a lot of different patterns, different styles, different strategies. And right now I'm a solutions engineer at Gradle. Some more background, I'm also maintain a couple of Gradle plugins. The first is called Fladle, and what it lets you do is easily scale your instrumentation tests on Firebase. Second is Delect, which easily replaces Dagger with Dagger Reflect to improve your build speeds. And the last one is called Gradle Doctor, and it gives you actionable insights for your build. Yes, right now I just started working at Gradle as a solutions engineer. What that means is I help our customers improve their Android builds and get onboarded to our enterprise product called Gradle Enterprise, which gives you insights into builds. Before we get started, I just want to clarify that Gradle is a company. We build the Gradle build tool. We also build and that's an open source project. And then we also have a Gradle Enterprise product, which helps large projects scale up their Gradle builds. That's just to give a distinction, because there's a lot of different companies we coordinate with, such as Google. Google builds the Android Gradle plugin and Android Studio. And there's also JetBrains, who builds IntelliJ and Kotlin. So we all work together to improve performance and make your builds more reliable every day. But I just to separate, there's a lot of different companies, and it's not always so clear what part of what product goes with which thing. So since I've been an Android developer, I know what it's like. You always have feature development and you have tech debt. Obviously, there's other things too. There's discussions, there's product research, all kinds of stuff. But in general, you can either work on feature development or tech debt. And I'm going to make the argument that if you're going to work on tech debt, there's refactoring and there's build speeds. But I'm going to say build speed is tech debt, and but it always pays off, because you're always going to build the build again, and if you make it faster, you're going to pay off that tech debt that you just saved. So you make your build faster, that's making your work in the future faster. Whereas sometimes you get caught up in these refactoring projects, migrating databases. It's happened to me before. You migrate a database, but then you never use the database ever again. So did that tech debt pay off? Well, I mean, it was fun. I learned something, but at the end of the day, when you're working on build speeds, you're always going to build the project again, unless your whole app gets canceled. So just to talk a little bit about the cost of builds, this is something that I stole from another slide from another Gradle presentation by Cedric. But if you have 60 seconds of waste in your build and you have 50 builds per day, which is pretty typical for an Android project, and you multiply that by 50 developers. So 60 seconds of wasted build, like, theoretical performance improvements in a build that exists, 50 builds per day and 50 developers, that it very quickly adds up. And I don't think sometimes it's hard to realize, but that's 42 hours lost per day, which if you're working a 40-hour week, that means you're losing 1 developer work week per day. So, and that doesn't even include lost focus, right? So fast builds really matter. You could hire 5 new people without paying them, no recruiting, the cost of onboarding, all that. So what I'm here to argue is that build speed is tech debt. It always pays off. And it's also easy to justify working on it because the numbers are very clear. Now that I have you motivated to work on build speeds, where to begin? This is always the question, right? My build is slow. What do I do? What do I look at? So the first thing I say is update all the things because we have a lot of teams here working on a lot of things to make your builds faster. And so simply by updating, you're going to get a lot of performance improvements. So as of this talk, the latest Gradle version is 6.5. The latest Android Gradle plugin is 4.0. Latest Gradle Enterprise plugin is 3.3.4. Latest Kotlin version is 1.3.72. Third-party plugins, you should also update them. Third-party libraries. But why? Like, what's going on here, right? This isn't like an iPhone where it gets slower every year. I can say that joke because I think you're all Android developers, right? But Android phones get slower every year too, right? So Gradle 6.5, for example, has new performance APIs that plugin developers can use to make the build faster. I'm just quickly giving, like, all these plugins and things have different sorts of things they improve with every version, but the Android Gradle plugin 4.0 has, caching improvements in 4.0, also task configuration avoidance. Another really interesting one is Gradle Enterprise plugin 3.3.4. It's the thing that uploads build scans. It now does background build scan uploads. So if you update, you won't have to wait for the build scan to upload before you install the app. This is a huge win for Android developers. Kotlin plugin 1.3.72 has compiler performance improvements, new flags to optimize your performance. Third-party Gradle plugins are also important to update because they use the new task configuration avoidance API, which can improve your configuration time. It's also important to upgrade third-party libraries. A lot of times they include improvements to incremental annotation processors. Okay, so you updated everything to the latest. I know it's easy to say just bump the version. Sometimes there's incompatibility issues, but if you really want all the benefits of a faster build, you should update everything. And if you don't know what the latest versions are, because obviously this slide is going to be out of date tomorrow as soon as something is updated, there's a Gradle plugin for that. You apply the Gradle plugin just like that, and you run the Gradle task dependency updates. It does it all for you. It tells you what's out of date, what's not. So I recommend using that Gradle plugin. Before we get started, I know one thing that I think was really challenging for me in making this talk is, well, one, I can't see all your faces, so I don't know what the experience level is of everybody in the audience. So my goal in this talk is to sort of give some tips that everyone can walk away with and some ideas to improve their build speed from people who aren't so familiar with Gradle all the way to experts. And so in order to do that, there might be some things at the beginning of the talk that, might be beginner stuff, or it might be new to you. So just hang on there. There'll be good stuff coming. Anyways, the Gradle build has a life cycle, and this is really important to know when optimizing Gradle, right? There's different areas you can focus on in a Gradle build. There's the initialization phase, the configuration phase, and then the execution phase. So the initialization phase is where Gradle sets up the environment for the build and then determines which projects will take part in it. This is documented more in the documentation, but this is basically figuring out how many projects you have in your build. The second part is configuration. All your build.gradle files are executed at this point in your entire project. So any piece of code you have in your build.gradle file, this is why if you just write a print line, it'll be executed in the configuration phase of Gradle. And then the last part is the execution phase. This will run the task graph that was computed in the configuration phase in order. So you can focus on different parts of these, mostly the configuration phase and the execution phase if you want performance improvements. And so yeah, let's get started. Where do we begin? Right, so first we do some things. We check for red flags. What is a red flag though, right? So first one to check is if nothing changes in your build, like if you're not touching any source files, no tasks should execute, no task should compile, right? So what you can do is if you run assemble debug twice, it says in this case, this build, there's 58 actionable tasks and 58 were up to date. So that's normal, right? But if you do something like that, where you run assemble debug twice, and then 3 tasks are execute, then that's a red flag, right? There's something going on in your build. You didn't change the code. Why are tasks running? So, and yet you should do this check regularly, right? Because plugins can change. You can update your code. When you have lots of people working in the project, things can change, and you don't know really what's going on. So it's always good to check regularly to make sure if you don't change any code, nothing happens. So yeah, when that is the case, what do you do? So if you run this in Android Studio, you get the Android Studio build analyzer. You can also get a Gradle build scan. I'll show you how to do that as well. The Android Studio build analyzer is a brand new tool in Android Studio 4.0. I'm not too familiar with it because it just came out, but I'll show you some insights you can gain from it. And then I'm more familiar with Gradle build scans, and I'll also show you some insights you can gain from Gradle build scans. So in this case, what did this build? What did it rerun? It was this inject Crashlytics mapping field debug task. I just noticed field is misspelled. That's kind of funny. Anyways, so what happened here? This task didn't declare its outputs, and therefore it's rerunning. Now, I'm not going to get too deep into like the intricacies of tasks and declaring its outputs, but basically it means the task ran, it did something, but it didn't tell the build what it did. So Gradle has no way of knowing what this task is doing. It doesn't know if it should be cached or not. So if you want a little bit more insights into this problem, you can run a build scan. It's as easy as adding -- scan at the end of your build. There's also a link to the documentation. And in the build scan, you can go to the timeline view. This is the same build I was showing earlier where the 3 tasks ran. And if you go to the timeline view on the left and you filter it by task with success, that just means any task that executed. It'll filter the tasks in the timeline to only show the 3 tasks actually executed in this build. And so further down the page, you see the 3 tasks that executed. In this case, that was the inject Crashlytics mapping field debug task that we just saw. And once again, you see it's up to date because there's no declared outputs. And then there's also the 2 other tasks that ran, desugar, debug file dependencies, and then package debug. If something changes about your build, usually the desugar and packaging tasks also have to run. So what can we, another insight to gain on this is like, okay, this task ran, but it's only 5 milliseconds. It's not that big of a deal. It is somewhat of a problem because it is changing things in your build without declaring the output. So that's not good for reproducible builds. I don't want to dive too deep into that issue right now. But another thing to note is that it's not just the task that was executed, but also plugin application can add some time to your build. In this case, it's only 80 milliseconds, so it's not that big of a deal. I mean, of course, we're looking at milliseconds, but maybe in your project, like the same plugin could have different behaviors in different projects. So it's always good to check what it's doing. There's other, crash crash type plugins. In this case, I just applied Bugsnag to the Signal Android app. The Signal Android app is an open source app. It doesn't have Bugsnag, but I just applied it just to see what would happen. In this case, 9 tasks run on every single build. Luckily, in their documentation, they have a way of disabling that. The Crashlytics, unfortunately, does not have a way of disabling it. And in this build, you can see what exactly the plugin is doing. In this case, it's also adding some time to the configuration phase of the Gradle plugin, and it's creating all these tasks. 86 in this case, even after disabling it. So I don't want to get into this whole perf matters thing of like talking about microseconds and builds. Like these plugins, you know, are just adding milliseconds to the build. It's not that big of a deal, but sometimes you have plugins, like the same plugin in a larger build will take up twice as much time. In this case, 100 milliseconds, right? And there's more tasks in this plugin, 545 tasks. Still not that big of a deal. You know, there's bigger fish to fry. If you look at the configuration phase in this build scan, sorry, we're going back to the build analyzer tool, right? So the build analyzer tool doesn't give too much insights into the configuration phase of Gradle, which is what we're focusing on right now. It does tell you over here that the configuration phase was about 4.5 seconds. But if you want to dive deep into that number, I recommend using build scans. So yeah, going back to red flags, right? If you have 5 projects and your configuration time is over 5 seconds, that's kind of a red flag, right? Before we were looking at microseconds, these plugins are taking microseconds, but 1 second for a plugin, that's a bit much, because that is 1 second added to every single build, no matter what you're doing in that build. And then also here, the Bugsnag plugin is taking a long time. Once again, I added the Bugsnag plugin. So, you know, sometimes, so in this case, there's it's a plugin called Witness. It's part of the Signal Android build. This is an open source project. You can take a look at it. And it's adding 800 milliseconds to the configuration time. Of course, you can rewrite the plugin. In this case, we can because we own it. But so yeah, what can we do about it, right? When plugins take a long time, and sometimes we see this in other apps, right? In this case, this plugin is adding 25 seconds to the build. That's really a long time. That's something to fix. So what can you do with these plugins, right? So one thing to test is, okay, let's just comment out the plugin. Sometimes you can just comment out plugins, especially for debug builds, and then rerun the build. In this case, so I disabled both Bugsnag and the Witness plugin in the Signal Android app, and now the configuration time is half a second. And that's a lot better, right? From 5 seconds to half a second, just by disabling 2 plugins. And that affects every single build. So no matter if you're just running help or whatnot, you're gonna get time savings. And so I guess after looking at a lot of Android builds, I can say, and this is really, really rough, and so I don't want to get a lot of flag, but your configuration time should be roughly 5 seconds per 100 projects if we're looking at Android builds, right? Can be faster, can be slower. You know, you might have your application plugin take up 1 second, but then all your other modules take up 20 milliseconds. That's fine. But you should be looking at roughly 5 seconds per 100 projects. If not, then you're that's a red flag, something to look at, right? So one thing you can do about it, if you don't control the plugins, is you can disable plugins for local developer builds, right? So we're going to talk about a pattern I've used in builds to optimize them. Actually, I learned this pattern at Square. It's called the engBuild pattern. And all it is a Gradle property. It's not a build variant. I know there are suggestions out there to use build variants to create a specialized build to improve for local developer builds. I'll talk about why that's not my method later on in a couple slides. So it's just a Gradle property. You can read about Gradle properties on this documentation. But what you can do basically is you can set this Gradle property, and it's really important to have these performance improvements in your build enabled by default, because when a developer checks out the build, you just want them to be a fast build. So this is a Gradle property. You can define it in your root project, and then you can use it anywhere else, just like this. And then what you can do is just not apply plugins, right? So you don't apply the Crashlytics plugin, you don't apply the Firebase plugin, and then your local developer build is faster. Simple as that, right? You can apply this to any plugin. And then on CI or locally, when you actually want to run the release build, then you disable engBuild. And that's a simple way of doing it. Another way, another thing you can do is you can just add engBuild equals false to your Gradle properties, so you can stick this on CI. And that's a very simple way of just disabling plugins for local developer builds. And that's the engBuild pattern. That's a hammer you can use in your tool set of improving Gradle builds. I'll get back to this engBuild pattern later on with some more tips, but just keep it in the back of your head that this is a thing you can do. And this is really similar to how, you know, the Kotlin plugin has a bunch of compiler flags you can enable. It's the same thing, right? You just enable a Gradle property and then your build does something different. Okay, so another thing to look at red flags in your build is lots of tasks being created. In this case, there's 16,000 tasks being created. A simple way of avoiding this is to use task configuration avoidance. This is a new API in Gradle. The docs tell you exactly how to, what to replace, the way you access tasks with another way. I won't get too deep into that right now, but I wanted to go to my controversial slides. So this is the API implementation. I've seen this debated on many Android teams from my experience, many teams, not just Android. So which one should you use, right? And really, so to understand which one you should use, you should understand what's happening, right? If you have module A, module B, and module C, and module A has a dependency on module B and C, and then module B just has a dependency on C, you can do a little shortcut here, and you can declare that module B has a dependency on module C using API. Now what that means is that module C is automatically added to the class path of module A, right? So if you're doing this pattern, you must always be certain that module C is always consumed together with module B, right? You always use module C when you're consuming module B as well. It's kind of like pairing them together. So it's really a trade-off of convenience versus performance. That's what this is. And so how do we prove that, right? And I don't just want to say, okay, convenience versus performance. I mean, a lot of times it makes sense to use one versus the other. We're all developers, we're lazy. There's shortcuts we can do. But let's take a look at a real world example. So this is the K9 Mail app. It's an open source app. It's an email app. You can find the GitHub repo right there. And it happens to use an API dependency on the in this one specific line. I'll link to the slides later in my talk. You can just click that line. And so what can we do, right? So going back to this tool of using Gradle or flags, in this case, we're just going to use a Gradle property. And in this case, we just call it use implementation. So when this Gradle property is enabled, we use implementation. Otherwise, we use API. This will allow us to run both builds side by side and compare the two, and we can profile it. So I'm going to give a quick intro to the Gradle Profiler. The documentation's right there, but basically you write scenarios and then you execute them to compare two builds. So if we make a change using the API dependency, this is what you write in your performance scenario file when you're using the Gradle Profiler. And then this is the task we want to run. And in this case, we're going to apply a non-ABI change to this one Java file. So that just means it doesn't affect the ABI of that Java class. It's a simple implementation change. And then we write another scenario. It's a, we just copy it, except in this case, what we're going to do is we're going to add that Gradle argument to use the implementation. So we have two scenarios here. The only difference is the use impl flag. And if we run the Gradle Profiler just like this with the benchmark, what it'll do is it'll stop the daemon, it'll clean your build, it'll run 6 warm-up builds and 10 benchmark builds. It is important to run a lot of builds because Gradle builds aren't so consistent. They kind of, sometimes take more time, sometimes take less time. So when you run the Gradle Profiler, then you'll get a report just like this. It's really beautiful. Actually, not really, but you also get a CSV file, so then you can export it to your favorite utility. So these are all the benchmark builds. And you can see that using API dependency in this case takes more time than the implementation dependency. Here you also get the mean and the median, the confidence, whatever. So it's about, this is in milliseconds, it's about 10 seconds for the implementation dependency, and it's about 11 seconds using an API dependency. So about 1.5 seconds of difference, which is about a 15% improvement for this one specific scenario in the K9 Mail app. Why is this though? So you can also use different tools to profile using Gradle Profiler, not just build scans, but build scans is the one I'm most familiar with. And it'll give you a nice report like that. You can click the links, and we can do the same filter we were doing before, filter the build scans by success. This is the build scan for the success, build scan for the API dependency. In this case, 14 tasks were successfully ran. And in the implementation dependency, you see that only 7 tasks were ran. Which tasks were ran? So here you can see the whole list of the API dependency. If you go further down in the timeline view on the build scan, and then here's the implementation dependency. Okay. So if we want to take a deeper look at why so many tasks ran in the API implementation, we can take a specific look at just one of them. In this case, compile debug Kotlin task. In this case, you see it tells you why this task ran. And in this case, it's because the class path changed, that reference to the jar where I made the change changed. So this task has to recompile because it has a dependency on that. If we want to know even more about the difference there, this is an enterprise feature alert. So this is what you can do with Gradle Enterprise. You can capture all the task inputs using a flag in Gradle, and then you can compare 2 builds. And here you see the 28 tasks with differences. And what you find is that for that same Kotlin compile task we were looking at earlier, in build B, it declares a dependency on that library where we made the change. Only in build B. Build B in this case was the one that used API. So that's a little bit of insight you can gain with build scan comparisons in Gradle Enterprise. So, and that's just a general thing. If you add unnecessary inputs to tasks, you're going to have more things recompile when you shouldn't. So how do we fix this whole API implementation mess? I have API all over my code. How do I know which ones I can remove? There's a dependency analysis plugin. This is written by Tony Robalik, and this will help determine which API dependencies in your build are unnecessary. You can read the docs, apply it to your project, and check it out. All right. So the next part, I'm actually kind of running short on time, so I'm gonna skip through this whole part. You want to make sure your annotation processors are incremental. You can see this in your build. For room, you can enable a flag, and that'll make it incremental. You have to get past the arguments to the Java compiler or Kotlin compiler. I apologize, I'm going through this really quickly. Another thing to note here is you get a remote cache miss. If you want to know more about those, there's a good blog post I wrote, so I won't go too deep into the details there. But one thing to note is that because you have both a cache miss and room's not incremental by default, although you can fix both those things using the Android cache fix plugin and applying the compiler flag, I like to recommend moving room to its own room or module. And this is a pattern you can apply to annotation processors or plugins or anything that's kind of slow in your build. It's a place to focus on when modularizing. So move that to its own place in your build. This is a cool new feature in the Android Gradle plugin 4.0. You can disable unused features. So what are unused features, right? So let's talk about the cost of generating the build config file. So this is a build, relatively large Android build with 186 projects, and so there's 186 generate build config tasks, and that adds about half a second to the execution phase of this build. But if you look at the avoidance savings, it's saving even more than that. It's about 21 seconds. So, if the build config weren't up to date, it would have spent even more time. And it's also unused, so ProGuard's going to remove it later, so it also adds time to your ProGuard in analyzing the build. And the other thing to note is that build config adds Java sources to your pure Kotlin modules. So if you have a Java, and what to note here is that there's a bit of a performance impact to having mixed sources within a module. If you have Java sources and Kotlin sources within a module, it takes a little bit longer to compile in order to make sure they interop correctly. The other thing is, like, it's just also not a good developer experience, right? You have, when you're typing and you get this autocomplete and you're like, how many build config files are there? The other issue is, like, if you're trying to pick up the version code, this can also lead to bugs. So if you accidentally pick the version code from a library project, which is 1 by default in library modules, then you're going to have a bug. So I recommend, there's also other features you may never heard of, such as the AIDL, which is part of the Android Gradle plugin. And so these features are enabled by default because it makes development easier, right? You can just stick an AIDL file in your build and it compiles automatically. You don't need to add anything to your Gradle configuration. And that's really great when you're just starting out. But if you have 186 modules in your app, you want to disable these features. And it also, this is the Kotlin plugin. It also eagerly creates these tasks. So anyways, there's a new feature in Android Gradle plugin 4.0. You can disable these features by default in your Gradle.properties file. I recommend disabling them all. And then what you can do is just enable them when you need them. So what you can do is do Android in any build.gradle file. So for example, your app build.gradle file, you enable build config generation there where you need it. Okay, so this last part of this talk, I'm getting really close to the end of this, is about code multipliers, right? Things in your build that multiply the amount of time needed to compile. The first one is Jetifier. It migrates support library dependent libraries to rely on Android X packages. What that means is it runs a transform. If you have this flag in your Gradle.properties, you're running a transform on every single dependency. So if you see this in your build, it doesn't appear in build scans, but if you upgrade your Gradle version, if you upgrade your Android Gradle version, you update your build source, you're going to run all these transforms again. So if you don't need it, I recommend disabling it, of course, but it's a little bit trickier than that. Lots of projects out there. There's all sorts of different constraints. There's also a small bug with dependency substitution in Android X, which will be fixed in a future release. There's an issue tracking that there. I don't have time to explain all the details of that, but the issue is very interesting. If you use dependency substitution, it's a gotcha to watch out for. So if you're stuck on the Jetifier, you should push the libraries you depend on to update, of course. But one thing you can do is you can use this Gradle plugin, can I drop the Jetifier? You run that task and it'll tell you what dependencies in your project still need to be Jetified. Another thing you can do is you can Jetify at home. If you just have one library that isn't Jetified in your project, just run the Jetifier on it and upload it to your Nexus and be done with it. That's my recommendation. Of course, from a security perspective, you might not be able to verify the checksums or use dependency verification on this, just something to note. But it might be a build speed win if you just have one dependency left or a couple that need to be Jetified. The next code multiplier we want to talk about is build flavors. This is, I think, something that comes up in every talk, and specifically flavor explosion. So what is flavor explosion? I didn't know, so I went to Urban Dictionary. Flavor explosion is when you drink something that is not what you thought it was, causing a surprising surprise. So what is this surprising surprise in an Android build? It's when you add a build dimension, multiplying build speed in a surprising surprise. So what exactly is that? Every build type you have, for example, debug and release, is multiplied by build flavor, let's say free and paid and Play Store, Amazon Store, whatever, and that's your build variants. And build variants are code multipliers because every single, so if you have most of your app in this module with all these build variants, that means that all that code needs to be compiled that many times. So if you have 6 variants, that means all the code in that module needs to run 6 times. 6 times as many tests are going to be configured in the configuration of your project. All the resources you have in that PNGs, whatever, they're going to use 6 times the amount of cache in your project. So what can you do about this? One thing you can do very simply is you can define a Gradle property. This is, this pattern I talked about earlier. You can just enable only one variant for debug builds by default. So if you have a lot of flavors, and this happens sometimes in builds for various reasons, you can just disable the variants you don't need, very simply. And then if you actually do need a variant, so for example on CI, or you need to check out the other variant, you can just enable a Gradle property to actually build that variant. Once again, it's important to run the Gradle Profiler to actually see that this makes a difference, right? On some builds, this might make only 10 millisecond difference. In that case, it's not worth adding this extra hassle of disabling other variants. But in some builds, might be tons of flavors, and this might actually save a ton of time. So it's important to, not just take my advice, run the Gradle Profiler and verify it. So yeah, once again, this is mostly configuration time win, but if you have flavors that you never ever use, you should definitely disable them. So this next one is how to cut build times in half. It's not actually how to cut build times in half, but it's very, very similar to the previous slide. So for all your library projects, right, you have the debug and the release variant. Assemble debug, assemble release. That means 2 times the code, just like I said before, 2 times the resources, 2 times the tasks, 2 times the tests. 2 times the tests, that's also another thing to note, right? So the question to ask here is how often in your build does the debug and the release code differ for all your library modules? Like if you have 100 modules, how many of those actually have different code in the debug and the release variants? It's usually like maybe 1, maybe 2, usually not that many. So why would you build all the code twice for all those modules? Even if you're not, you're only using the debug variant locally, you still need to build it twice on CI. That adds CI build times. It also gets a little bit confusing if you run, if you run the normal Gradle lifecycle test task, runs all your tests twice. That's really, that's kind of a time waster. And if you run test debug, that's not going to run. If you have Java only modules, it's not going to run those tests. And then what's also really annoying is if you switch, sometimes you do need to test the release variant and you switch to it and then you have to recompile everything. And like I said before, you see it takes twice as long. So what can we do about it, right? So what I was talking about earlier, the engBuild, you can use the variant filter we were talking about before. If the variant is release and your library modules, you ignore it. So this will never build the release variant. But there's actually something you can do that's even a little bit better than this, which is disable the debug variant. Always use the release variant. And if you also disable the build config generation, the debug and the release variant are going to be exactly the same. And in that case, you don't need to only do this on engBuild, just do it for all the builds, all CI builds, all local builds, every single build in your project, just disable the debug variant for library projects. And then one thing you'll have to do is, for your application module, you can just add the matching fallbacks to the application module. That way you'll just pick all the release variants of all your libraries. And just like that, your build times will be cut in half. And the other benefit is, when you do need to test the release build, you don't have to recompile everything. So I guess what the lesson here is, disable stuff, right? Use Gradle properties, find out what you can disable. There's a lot of stuff running. Disable it and measure it. One thing you can do is to measure is configuration time. So I went ahead and I did a performance analysis of some of the things I talked about today. I ran a build. The standard build is at the bottom. Everything's enabled. The one at the top, I disabled the debug variant of all the library modules. The one in the middle, I disabled the debug variant and the Android Gradle plugin features that weren't needed. And this is run on the K9 Mail app. And what you can see is this is just the configuration time. So it's not compile time, nothing like that. Unfortunately, it's a really long time to run profiling for all these builds. Okay, so yeah, you can see that this is about 13% faster, 13% configuration time improvement, and this scales to all your builds. So if you have a way longer build, I just got word that I need to wrap up, so I'm gonna run through these slides. So yeah, you can see this is the regular build, the 500 tasks configured, and then when you're debug mode, there's the Android Gradle. Yeah, you can see a lot less tasks are configured. There's more things you can disable. There's a new APIs in the Android Gradle plugin. Here's a link to it. Some other ideas you can do in engBuild is have a higher min SDK. This disables multi-indexing. It disables core library desugaring. Other things you can do is strip out other languages, strip out large images, strip out native libraries so you don't have to compile those, try new versions of AGP. These are just ideas you can add to your own engBuild to make your build faster. The other thing is always measure. So I just want to give a sneak peek of upcoming performance enhancements before I let you all go. First one is file system watching. This is an upcoming experimental feature in Gradle 6.5. What this does is if you have a build with long snapshotting in task inputs time, such as this build where it's 6 minutes, that'll drastically reduce that time by watching the file system. You can enable it with this flag. There's a blog post about it that talks more about it. The next one is configuration caching. So if you have a build with a long configuration time, your build has to execute all the tasks for all the project. So what you can do is, well, upcoming in Gradle, we're working on a feature to cache the configuration. So this will mean you don't have to do configuration time. I'm gonna skip this part of the build. This is talking about how configuration caching works. Okay, some other talks, some other resources if you're interested is this talk by Cedric Champeau. This was about 2 years ago, but Android builds, the same basic principles of improving Android builds haven't changed much. Actually stole some slides from this talk. There's also a really good talk by at Google I/O 2019 on scaling on different features and Gradle features you can use in scaling your build for large projects. I've also got to plug my own talk. This talks about certain build performance improvements that you'll get by like sharing the Gradle daemon or talking about garbage collection time, things like that. You can also measure the remote build cache performance. I have a blog post there. These are just some resources, blah, blah. Okay, I got to wrap it up. I think I'm way over time. I really apologize for that. So now I'm going to get started on questions. Okay, is there any information available about how much capped plugin slows down builds and how to improve on these build times, like Dagger and Dagger Hilt? So this is a really good question that comes up a lot. Build scans show how much time is spent with normal Java annotation processors, but they don't show how much time is spent with capped. However, there is a flag you can enable in the capped extension. I think it's show annotation processor times or something like that. And using that, then you can see how much time is spent with these annotation processors. I also talk about this in the talk I linked about the internals of Gradle, and the Gradle Doctor plugin that I built actually measures all the time that capped is spent with Dagger as an annotation processor specifically. So I recommend checking out my talk if you want to know more about that. Okay, what about release build with ProGuard and all obfuscation? It consumes more time than debug build without it. So yeah, you're still gonna have the release build. It's still gonna take a lot of time with all the obfuscation, but you won't have to recompile all the dependent libraries. Also with ProGuard, the improvements to D8 and R8 will, make the ProGuard time a lot faster. There's also things like the number of rounds that ProGuard and D8 and R8 and whatnot are making on your build that you can tweak to improve that time. But yeah. What is a lower bound to expect from Gradle builds when there are actual code changes made? What is fast? That's a hard question to answer. It really depends on the size of your project, how many lines of code are in there, how many developers are working on the project. Well, actually that one doesn't really matter, but just the lines of code. So I can't really give you a good answer, but actually one I can give you is when I was working at SoundCloud, our average build time on local developer machines was 50 seconds on average. So that's, I don't know, that's a fairly large app, and that was the average build speed. Does API versus implementation really matters when using Kotlin? As far as I know, Kotlin doesn't support compile avoidance. That is true. Kotlin does not support compile avoidance. The K9 mail app does use a mix of Kotlin and Java, and so that, but the tasks that were rerun and not rerun and avoided in the sample I gave, those were Kotlin tasks. So it does help with Kotlin. Oh, does the 5 seconds for 100 projects apply when using build source? Notice my configuration times are 7 seconds total with build source using 5 seconds. Yeah, I would say it probably still applies if your configuration time when using build source is long. That might indicate something else, something being rerun. So there might be something to investigate as well.